Hi everybody, let's look at the effect of data changes on dispersions of distributions. So what I'm talking about here is they change uniformly. For example, if I have a set of data which consists of 5 data, x1, x2, x3, x4, and x5. They change uniformly. It means that they change in the same manner. For example, if one of the data times 2, every single data for that set of data will times 2 as well. Okay, so if every single data, let's say if the first data times 2 plus 1, the rest will change in the same manner as well, times 2 plus 1. Okay, and so on. So this we call it change uniformly. If they change uniformly, then we can apply the concept here that I'm going to share with you. If they change non-uniformly, for example, this one times 2, this one plus 1, this one divided by 3, then we cannot apply the concept here. Okay, so now if every single data changes in the same manner, they change uniformly, what is the effect of the new interquartile range, new variance, and new standard deviation? Okay, now let's look at here. If let's say every single data plus k or minus k, the new interquartile range, new variance, and new standard deviations remain unchanged. Okay, so the plus and minus will not affect the new interquartile range, variance, and standard deviation. But when we come to multiply and divide, yes, they will affect the interquartile range, variance, and standard deviation. So you will notice that here I only write multiplying constant value of k. So how about divide? Okay, let's say divided by 2 is actually the same thing as times 1 over 2. So I only write multiply, but same thing apply for divide. But you have to be extra careful when we go to variance. If every single data times k, the new interquartile range will times k as well. The new standard deviations will times k as well. But when we go to variance, it's slightly different because you have a square here. So you have to times k squared. Okay, be extra careful for variance. So how about divide? Same thing. If every single data divided by a constant value of k, the new interquartile range will be divided by k as well. The new standard deviations will be divided by k as well. But for variance, it will be divided by k squared. Okay, so now let's look at this example. Okay, let's look at this set of data. So I have 5 number over here. So besides sharing with you about the measure of dispersions, let's do a quick revision about the measure of central tendency. Okay, so be more careful. Just now I told you that if every single data plus or minus by a constant plus k or minus k, every single data changes the same manner. Okay, let me use a different color. Plus, minus, time, divide. These two will not affect the new range, interquartile range, variance, and standard deviation. Only these two will affect. Okay, but when we come to this measure of central tendency, mean, mode, median, which you learned before, plus, minus, times, and divide, every one of them will affect the new mean, new mode, and new median. Okay, let's see what happened when every single data changes in a same manner way. Okay, now I have 2, 3, 4, 4, 5. I think it should be no problem, right, to get the mean, the mode, and median. Okay, let me use a calculator. So if you have a calculator, you can try use the calculator to press. So change statistic. Okay, then we choose one variable. Okay, now I'm going to key in all the data here. So 2, 3, 4, 4, and 5. Okay, then press, so make sure you have key in 5 data, double check again. 2, 3, 4, 4, 5, correct or not? Okay, 2, 3, 4, 4, 5. Okay, then press this options, one variable calculations. Okay, so now I will get all the mean, a lot of data here. Okay, let me make it bigger. Okay, so the mean is 3.6, right? The mean is 3.6, and then the mode median. Okay, you can get the median as well. The median is 4. Okay, let me call. Okay, same thing. Range should be no problem. You just take the biggest value, 5 minus 2. Then you will get the range. In the quartile range, we take the. So this calculator is actually very convenient. It can show you the third quartile, the first quartile. You just take these 2 minus, you get in the quartile range. And then for the variance, 1.04. Standard deviations is 1.02, 1.0198. Okay. So later on, you can try to use a formula to help you to calculate. Okay, so I have copied down all the data all the information that we need. So how about now we try if every single data minus plus 1, let's say every single data plus 1. So the new set of data, okay, this is for plus 1, huh? So plus 1, then you will get 3, 4, 5, 5, 6. Okay, 3, 4, 5, 5, 6. So now let's see what's the new mean, new mode, new median, and also the new measure of dispersion range, interquartile range, variance, and standard deviation. Okay, so what's the new mean, new mode, new median? So for mode and median, we just look at this. We know the mode is 5. And the new median is also 5. Okay, new mean. Okay, how about we use our calculator to help us check the answers. So we change all the value now. It becomes 3, 4, 5, 5, 6. Okay, 3, 4, 5, 5, 6. Okay, always double check again, correct or not? 3, 4, 5, 5, 6. Okay, press options, choose the third one. Okay, so the new means is 8. I think maybe I keyed wrongly. Okay, hold on. Oops, sorry, this one I think I calculated wrongly. This is not 6. Okay, let me calculate again. Should be 3.6. Okay, let me check again. Maybe I see it wrongly just now. So 2, 3, 4, 4, 5. Okay, let me key in again. The calculator should be correct. I think maybe I key 2, 3, 4, 4, 2, 3, 4, 4, 5. Okay, 2, 3, 4, 5. Okay, let me check again. Oops, not 6 but 3.6. Here is 3.6. Okay, so how about the rest? Correct? Not mode, no problem. Median should be correct. Okay, so let me check for the rest. Range. Okay, in the quartile range, 4.5 minus 2.5, variance 1.04. Okay, the rest correct. So this one is not correct, sorry. So it should be 3. 3.6. So this should be 3.6. Okay. So let me change all the data to the new set. 3, 4, 5, 5, 6. 3, 4, 5, 5, 6. 3, 4, 5, 5, 6. Okay, correct. Okay, so the new mean is 4.6. New mean is 4.6. Let me write down. This is 4.6. So how about the new range, new interquartile range? New range should be no problem. Range, you just take 6 minus 3, you will get 3, right? So new range is 3. Okay, so when we come to interquartile range, we just take 5.5 minus 3.5. You will get 2, right? And the variance 1.04, you see, remain unchanged. How about standard deviations? 1.0198 remain unchanged. So this is 0.2, 1.04, 1.0198. Okay, that's why I told you just now. For measure of center tendency, mean, mode, median, plus, minus, times, divide, all will affect the new set of that, the new means, new mode, and new median. You see, if this is 3.6, right? Since every single data you plus 1, the new means, new mode, new median, you also plus 1. 3.6 plus 1, 4.6. 4 plus 1, 5, 4 plus 1, 5. But for the new range, interquartile range, variance, and standard deviation, they will not change, remain unchanged. 3 to 1.04, 1.0198. You see? Exactly the same thing, right? Same thing, if you minus every single data, you minus 2, only this will change. This will not change. So how about multiply? Okay, let's see. So how about we try multiply by 2. If every single data I times 2, then you will get 2, 2, you get 4, 3, 2, you will get 6, 4, 2, you get 8, 4, 2, you get 8, and 5, 2, you get 10. So now let's me key in all the data into the calculator and get a value that we want. 4, 6, 8, 8, 10. Okay, let me change the value. 4, 6, 8, 8, 10. Okay. So in case you still don't understand how to get the mean in the quartile range, variance, standard deviation, you can watch back my previous video. I show you how to get the variance. I use a formula and how to get the standard deviation and so on. Okay, so the new mean is 7.2 and the new variance is 4.16. New standard deviations is 2.0396. And when you go to interquartile range, median, in the quartile range, you just take the quartiles minus the first quartile. Okay, let me copy all the informations that we need first. Okay, so do you notice that if every single data we times 2, right? All the value for the measure of center tendency, 3.6 you times 2, for the mode you times 2, the new median you times 2, right? Same thing for the measure of dispersion, except the variance. Variance a little bit different. New range times 2, you get 6. New interquartile range times 2, you get 4. New standard deviations times 2, 1.0198. 1.0198 times 2. Okay, so it changes to decimal, 2.0396. Okay, but there's variance, extra careful variance. It's not times 2, but times 2 square. Okay, let's see. 1.04 times 2 square. 4.16. Okay, so when we go to new variance, be more careful. Okay, so let me repeat again. For measure of center tendency, mean, mode, median, plus, minus, times, and divide all will affect the value of new mean, new mode, and new median. But when we come to measure of dispersions, range, interquartile range, variance, and standard deviation, only multiply and divide will affect them. And be extra careful for variance. You have to square it. If every single data times 2, the new variance times 2 square. If every single data divided by 4, the new variance divided by 4 square. Okay? Let's try one example. Okay, so let's look at this example. The range, interquartile range, variance, and standard deviations of a set of number. We don't know the number. The question just gave us x1, x2, x3, x4, and x5. So 8, 6, 16, and 4. So for this, I will encourage you to write down the important information so that we won't mess up. Range, interquartile range, IQR, interquartile range, and then we have variance, square. So variance, you need to square it. If you use this symbol, right, you have to put square. Okay, and the last one is a standard deviation. Range is 8, and this is in the quartile range 6 and 16. The last one, this is always a square root of this, so we get 4. So how about write down the range, interquartile range, variance, and the standard deviations of each of the following. So this is new set of data. So they change in the same manner. Every single data you plus 4, then you times 2. So since they change in the same manner, you can apply the concept that I told you just now. Range, interquartile range, then the variance, and the last one, standard deviation. Okay, correct. Not range, interquartile range, variance, standard deviation. Yes. Okay, for the range, so be careful. This measure of standard tendency, range, interquartile range, variance, and standard deviation, plus and minus will not change their value. Only multiply and divide. Okay, we'll repeat that right here again. Okay, so these two will not affect them. Only this and this. So the 4, just to make you confused, you just forget about the 4. So the new range, 2 times 8 is equal to 16. The new interquartile range, 2 times 6 is equal to 12. The new variance, be extra careful when we go to variance. We cannot take 2 only, but 2 square times the original variance, 16, right? So this is 32. Okay, sorry, not 32. This is 4. 4 times this is 64. So this is okay, correct. So this one, no problem. 2 times the original standard deviation, so this is equal to 8. 16, 12, 64, 8. Okay, so this is the answer for part A. So how about part B? We want range, interquartile range, standard variance, and the last one, standard deviation. Okay, so be careful. This minus is just to confuse you. Forget about this. It will not affect the range, interquartile range, variance, and standard deviation. But if this question is asking you to find the new mean, new mode, and median, measure of central tendency, yes, the minus and the divide all will affect them. Okay, so new range divided by 3, so we just take the 8 divided by 3. So this answer. If you want to change to a mixed number, also can. If you don't want, it's okay. So the interquartile range, 6 divided by 3, which is equal to 2. Okay, so this is Variance, extra careful. 6 divided by 3? No. 6 divided by 3 square, which is 6 divided by 9. And we simplify it. You get 2, oh, not 6, sorry, 16. 16, okay, so this is not correct. 16, right? 16 divided by 3 square, 16. So this is answer. Same thing, if you want to change to a mixed number also can. Last one, let's go to standard deviation, 4 divided by 3. Okay, so this is the answer. Okay, for this video I stop here first. Thanks for watching. See you next time. Bye bye.